Hi there. In this video, we will go over AWS Elastic Kubernetes Service. To understand Elastic Kubernetes Service, first we go over the entire ecosystem of containers, container engines, and container orchestrators. So, first of all, containers are everything that is required to run an application. The container contains the application code, system libraries, and other dependencies. Now, for a container to work, it needs a container runtime engine. The container runtime engine is software that accepts user requests, including command line options, pulls images from the container registry, and from the end user perspective, runs the container on a host operating system. Some of the examples of runtime engines that are available in the market are Docker, LXC from Linux, and Containerd. Other than container runtime engines, you then have container orchestrators. Container orchestrators are systems for automatic deployment, scaling, and management of containerized applications. Some of the container orchestrators in the market are Kubernetes, Red Hat OpenShift, VMware Tanzu Kubernetes Grid. Now, in between the two, between runtime engines and container orchestrators, we have container managed service. Container managed service provide container orchestration, plus they provision the hardware resources, which is basically the compute, to run the containers. So some of the examples of managed container services are from AWS. If you're looking for Docker, you have Amazon Elastic Container Service, you have Azure Container Apps, and Google Cloud Build, designed for managing Docker containers. If you're looking to run containerized application on Kubernetes, then you have Amazon Elastic Kubernetes Service, Azure Kubernetes Service, and Google Kubernetes Engine. So let's understand, why do we need Elastic Kubernetes Service when Kubernetes itself is a container orchestration service? So let's see how containers are run on Kubernetes. What we have over here is an image of the Kubernetes cluster. The Kubernetes cluster is comprised of the master node, also known as the control plane, and the various nodes. Now, the components of the control plane are the API server, which is the front end for the Kubernetes API server that validates and configures data for pod services and replication controllers. You have etcd, which is a highly available key value store that provides the backend database for Kubernetes. You have the controller manager, which is the daemon that manages the Kubernetes control loop. It watches etcd for changes to objects such as replication, namespace, and service account controller objects. And then you have the scheduler, which is a function that looks for newly created pods that have no nodes and assigns them a node based on the host of requirements. So this is what the components of a control plane is. Then you have the nodes, and the nodes comprise of a kubelet and a kproxy. The kproxy takes care of all the networking. The kubelet contains the pods. Pods are what contain either one or more than one containerized application. So when we say that the scheduler is a function that looks for newly created pods that have no nodes, the pods go inside a node which are basically contained within the kubelet over here. Now, this running of a Kubernetes cluster is a complex task, especially as your application becomes very large, or if you're using a hybrid structure to run your cloud infrastructure. So in such a situation, you get Elastic Kubernetes Service. What Elastic Kubernetes Service does is, it takes care of managing the control plane. Traditionally, running a Kubernetes native software architecture gives you complete control over the cluster control plane. However, this by itself is no easy task. It does make sense to use a managed service such as the one provided by AWS. And what AWS does is, it basically takes care of running the control plane across multiple availability zones and leaves it to the user, which is the client, to run their own nodes and their applications and run them across various availability zones. So a managed service like Elastic Kubernetes Service from AWS or Google Kubernetes Engine or Azure Kubernetes Service manage the cluster control plane. Now let's go over the differences between Elastic Container Service and Elastic Kubernetes Service. What's the benefit of using this AWS managed service? You use ECS if you want to deploy a containerized workload via simple API without complex abstractions. It is ideal for Docker applications. EKS helps to manage, install, operate, and manage your own Kubernetes control plane, which is the most complex part of Kubernetes. What is the use case? ECS is for simple containerized application. EKS is for highly complex or hybrid containerized applications. Platform portability. ECS is AWS opinionated, which means that migrating ECS containerized workloads to another cloud service provider like Google or Azure is extremely complex or difficult. EKS is provider or platform agnostic and allows you to package your containers and to be able to move them to another platform quickly. Handling networking and support components of container orchestration. ECS relies on AWS provider services like ALB, Application Load Balancer, and Route 53, whereas Elastic Kubernetes handles all these mechanisms internally. Security. ECS has a deep integration with AWS Identity and Access Management, whereas EKS requires add-ons to enable IAM functionality. And then finally, community support. ECS is by Amazon Web Services. It is not an open source product, so there is no community support. Whereas Elastic Kubernetes Service is based on Kubernetes, and Kubernetes itself has a vast ecosystem of Kubernetes tools, community tools like GitHub, repos, Slack channels, events documentation, and training resources. To finally end off, let's go over some of the essential concepts of Elastic Kubernetes Service for the Solution Architect Associate exam. Now, for the concept of EKS, the important domains of knowledge that we should know about are how to design resilient architectures, how to design high-performing architectures, and how to design cost-optimized architectures. Within domain 1, it is critical we know how to design a multi-tier architecture solution and design highly available and fault-tolerant architectures. EKS achieves this domain knowledge requirement because it achieves high availability through various multiple worker nodes that are placed across availability zones that ensures your pods, which contain your containerized applications, will always have a worker node across AWS availability zones. EKS leverages the architecture of AWS regions in order to maintain high availability. A Kubernetes cluster will have multiple master nodes, and the master nodes run in different availability zones. So even if one master node is active and operating the whole set of worker nodes, in case that master node goes down, there is one of the inactive node that takes over and becomes the new master node and runs all the worker nodes across the availability zones. Secondly, in terms of designing high-performing architecture, we need to identify elastic and scalable compute solutions for workload. And we need to choose appropriate architecture and services that scale to meet performance requirements. EKS helps to scale because it actively monitors the load on control plane instances and automatically scales them to ensure high performance. It automatically detects and replaces unhealthy control plane instances and restarts them across the availability zones within the region as needed. Finally, in terms of designing cost-optimized architectures, you need to identify cost-effective compute and database services. You need to select appropriate scaling strategies from a cost perspective and select and size compute resources that are optimally suited for a workload. So EKS typically is charged pay as you go. However, you do pay 10 cents per hour for each EKS cluster that you create. You can use a single EKS cluster to run multiple applications. Now, EKS is the container orchestration platform. Plus, you also get the hardware, which is the compute resources. So if you're running EKS on EC2, then you only pay for the AWS resources such as EC2 instances or Elastic Block Store volumes that you create to run your Kubernetes worker nodes, and you pay for what you use and only as you use it. If you're using EKS on AWS Fargate, which is a serverless solution, then the pricing is calculated based on the CPU and memory resources used from the time you start to download your container image until the EKS pod terminates, rounded up to the nearest second. If you're using EKS on AWS Outpost, then the pricing is simple and works the same as it does on the cloud. The EKS cluster is deployed on the cloud and you pay 10 cents per hour. So this concludes our video on the essential concepts of Elastic Kubernetes Service. In the next video, we will go over Elastic Beanstalk. So I hope you like this video. Please keep watching our videos, subscribe, and hit the like button, and keep watching. Thank you.